Hello, everyone, and welcome to the ninth in our series of video demonstrations for the VPAT tool. In this video, we're going to go into the simulation functions, and we do so by clicking on the simulator option in the menu bar. Now, when we click on simulator, we get a series of new menus here that show up. Now, it's important to understand what simulation does. Simulation is a modeling technique that VPAT uses to construct a representative model for selected workloads, selected service classes during a selected interval. So perhaps a peak interval that's of interest to you in modeling. What VPAT will do is construct a representative model of that workload. Well, that means that it's going to have a representation of that workload that can then be run on other target systems to simulate what your performance will be on those systems. So if we upgrade, we should expect to see an improvement in performance. And if we intentionally constrain a system, we can actually anticipate the anticipated reduction in performance. So this can be very helpful to assure that our LPAR, our workload manager policies and priorities are set properly. It can be useful in anticipating surplus capacity on target systems. So we have a lot of different things that can happen out of this, but the basics are that we're going to go into build, and our first effort here is going to be to say build. So we're going to build a model, and that means we're going to take our existing system and we're going to have VPAT create something that will represent our workloads in that system. So what we're going to do is we're simply going to go in here and we're going to select our CPU report file, and we're going to go to our same demo one data, and we're going to use our LPAR report file that we created earlier. Okay. And we're going to, again, the same vMIPS. Do we want to customize these for zPCR or use our defaults? We're going to use our defaults. So now we've got everything specified here on our configuration and how fast our processor speeds are. We do need to provide some zip information because the system is going to look at how zip offload works as part of constructing the simulation. So the workload simulation will include understanding distribution of work to zip engines and overall zip engine busy, so we can see resultant performance. Now, we do need to go to the service class level, so we are going to need to point it to our workload file, which is our WGL file. And we are now going to be given the opportunity to pick that LPAR and that date and time instance where we want to use to select our model from. So again, here's our prod 3 system, and let's go to that 100% period that we saw in there, and we can scroll down to see where we were most busy. We can pick any desired interval, so we can pick, let's pick this one here. Doesn't really matter. We will pick the 49% busy. Let's look for an even busier period on our production system here. Here's a 76% busy. Let's pick that one. So we'll click that. We've now got the date and time selected. And now we're going to go in and look at what workloads do we want to put into the model. This is a list of our workload by priority. Now we know that higher priority workload is going to get preference on the CPU in a situation where we might constrain a workload. So in this situation, let's take a look at some of our DB2 functions. So we'll look at DB2 high. And now when we select each workload type, we have to tell the model how it works. Is it a multitasking workload where there's multiple concurrent TCBs? Or is there really a single primary TCB? Or are we talking about batch where we've got a variable number of things that are going on? So DB2 is going to be a multitasking workload. And we're going to pick our DB2 medium and DB2 high service classes that we're going to include here. And I think we should also look at CICS because it's a little lower. So we're going to look at CICS medium. Now, unfortunately, CICS is still a single tasking workload. We still have that primary TCB in there. We really don't have true multitasking in there. CICS does have multiple subtasks, but they're not usually at the task level. So we're going to leave it, say, as a single tasking workload. And we can even go down a little further and look at some lower priority work. Maybe we want to look at how is our DB2 default workload going to run. Let's look at our batch default. So we'll add in batch. Now batch is batch. So here we go. Now, once we say build, what's going to happen is VPAT is going to say, do you want to change anything? I've got your information. Do you want to modify the work? Do you want to modify the weights that I'm working with and when I'm evaluating how much CPU is available in building my model. Should I alter it? So we're going to focus primarily on this LPAR here. He's going to keep this workload the same static in these other systems. But if we wanted to simulate taking some capacity away from somebody, well, we easily could by changing some of these weighting factors here, and the model would then reflect the updated CPU distribution. We don't have any group capacity. We don't have any capping controls in place. So we're simply going to click on OK. We're now going to, we have to go through the zip engines. And again, we're going to leave our existing configuration as is. And once we click that, we are now going to see how the tool is going to create and simulate its model. And basically, we've got our service classes in priority order selected, and the tool is going to use static data essentially for the workloads that are sitting between us. So it'll assume that those workloads are going to consume the same amount of CPU. What we're interested in is how our selected workloads change in performance. Again, we're going to leave our differences alone here. These are defaults that are calculated by the product. There's much more information in the product manuals about what you can do with these numbers to enhance or alter the results. But generally, we will leave them as default. We're going to click OK. And we're now going to see here that we can click OK, or we can, the maximum arrival work is for workload number 4 is a fill rate. So we're going to leave that alone. So we're going to leave OK to continue because we're not really interested in number 4. So we're going to say OK. And now what we see here is that the tool is running a series of calculations to produce a model of our base workload. And it's now done. So that part is in place. And it gives us some results here, and it gives us some of the controls that were in place in use. And then again, this is just information on the underlying data that's been retained. The real important part here now is that we want to do some runs, okay? And what we want to do is we want to take this base build, and we'd like to do a run where we can use multiple target systems and see how our performance will change. So we do run wizard. We're going to say, yes, save our model, okay? So save this model that we just created. We like that. We're going to say save, and we're just going to leave a default name as build.sim. You can make this anything you wanted. If we're CICS and DB2, we might want to look at this as CICS and DB2.sim. We'll leave the default alone, and now we've created this model. And now the tool is going to say, okay, you have a model. What is it you'd like to do? Well, we're going to select that model, which is build.sim. And now we can specify some growth, but we're actually going to just leave this alone because, again, this is a little more advanced, and we just want to show the basics of how this tool would work. Now, if we run this right now, what it's going to do is simply show us our current results. It's going to show us what the mathematical model shows as our performance on our current system. But what if we want to see what happens? What happens if we intentionally constrain our system? And what happens if we reduce it to a 709? Or what happens if we even reduce it to a 708? So we can do all this here, and we can even specify, well, let's say we want to do that growth, and we want to show the 711 also that we talked about in our capacity planning model earlier. Again, we could save and then reread these screen definitions and all of this information if we wanted to, so we could come back and run this multiple times. But instead, right now, we're just going to click on run. Okay, so now we have to go through each of the LPARs that we're going to modify, and we have to review the processor configuration for them. We saw this in the earlier build, but this is similar to that where you want to verify the definitions that are going to be in place. That was for our GP engines. This is going to be for our zips here. So we're going to click OK. And now it says, looks like the first processor that we're going to do is the same as our base. So we don't need to rerun that at all. Okay, we already have the base data there. We're going to say skip. And now we're going to go through each of our targets. This is our 709. Do we want to alter the configuration? No, for now. We'll click OK. There's our 709 zips. Again, 708. We'll say OK, going through both. Again, we could alter the configurations here if we wanted to see, well, how would things perform if we gave different LPARs different weights on different machines. But we're going to leave all defaults alone just so we can see something that's basic interest here. And now it says, well, where do you want to keep the results? I want to keep the results. I want a disk file that the system can use internally, and I want a printed file that I can actually access myself later on. So now, again, that same warning about the 4th workload there, but we're not modeling the 4th workload, so we can ignore that. So we're going to say, okay. Now we're going to let the system run, and we're going to see it go through a series of churns now. And each one is going to represent multiple passes, potentially multiple passes through each of our target machines. So we'll take a few minutes for each one to run. We've selected 4 target machines, and it's going to produce it for GPs and zips on each. So we have to let the system take its time and run. But each time it's doing this, it's taking it as, this is our second model. Again, skip the 4th workload. So we're going through each machine, and it's mathematically, iteratively calculating and creating a workload that will simulate this workload on a target machine. So how many accesses to central storage, how many IO accesses. We can actually modify the anticipated IO speed. If we've got a massive change in processor architecture, we can even model that. We can model a number of changes in here at the system level to help us better anticipate performance. In this model, we're leaving everything defaulted, and we're just going to show the basic results of projecting our workloads on multiple target systems. So again, each one's going to run slowly. It's doing a lot of mathematical calculations on your PC. It's creating multiple iterative models and evaluating them for accuracy. And each time you see the numbers changing, it's making a slight change to the representation of that workload. So we're coming up on our next to last, or our last model right now. And again, you can see the numbers changing as it works through. It repeats numbers of transaction processing with different workloads on different LPARs and different workloads on competing systems or competing workloads. And it will actually calculate and make sure that the anticipated results are as accurate as possible. And this will become more apparent as soon as we get to our results panel. And we are now done. So let's delete our temporary files that the tool worked with. And we're now done. Okay, so this is the model that we've created. We can make a chart out of this if we want. But what we want to do is we want to say results. And then we want to simply point it to this file, which is our output file. Remember, we saved output before as sim.txt, and we saved the sim.num file. Num file is the one that the tool will use internally. When we click OK, we now get an interesting display that shows us a number of things. So when we look at our initial row on top here, this is our baseline performance. So our average response time in DB2 is 0.0515 seconds. So 500th of a second is the average, or the modeled response time during that interval. And these are our response times on our different systems here. And it's not so important to look at these numbers. It's important to look at the anticipated change to these numbers. So as we reduced our system size, we went from a 710 to a 709, we've had an 8% change in reduction in CPU's capacity. Okay, so it's 8.47% smaller. The MIPS per CP has actually gone up by 1.7%. So smaller machine, reduced number of engines, less MP, less multiprocessor overhead, so more capacity per engine. It's anticipated that we're going to have an increase in our total busy. We were only at 76% during this interval. We're going to rise up to 84% total busy on the machine. Okay, so we can determine how busy our model here. So our system that we modeled out was 68% of that workload, and that's good. That's a 10% increase. So that's about the same. We expect that. We can see our zip engines have gotten a little busier. Okay, that's okay. We can see how we can compare that. What's interesting to see here now is that, well, we've constrained the system and our DB2 performance has degraded. It's gone up by 1.8%. Our DB2 medium workload, well, it's probably unchanged. It's probably a lower workload, lower volume workload. So it probably wasn't changed, or its application path was such that it didn't have a change when we put it on the larger system. Now, again, this is a higher priority than CICS. CICS shows a 4% reduction in anticipated degradation in response times. Our batch shows a mild increase in response time. Now, that's probably because it's the same amount of workload, but running on faster engines. So we can see a lot of different information here. We can see that as we constrain the system down to a 708, we've got a continued reduction in capacity. We've got a continued increase in total busy on the machine, and we've got a continued degradation of performance here. We've got an additional 2% degradation in DB2 response time. We've got a 12% degradation now in CICS response time. So these are decisions that can help support our capacity planning decisions by actually looking at modeled workload results and making sure that we're going to get the results that we want. Now here, this is statistically neutral when we've gone to our upgraded machine. Okay, and we anticipate we're going to get a reduction in DB2 response time and a reduction in CICS response time, given our current workloads put on a larger machine. So this is the real value we can get out of the modeling tool. And like I said, this is just scratching the surface of what can be done with this tool. There's a lot more information in the manual, and there's a lot more information by contacting us for support with this tool. Thank you very much. I hope you found this interesting.